So hello everyone. I hope you all are doing well. So today we are going to discuss that third lecture of the oscillation. Already we know some basic fundamental of oscillation and what is the linear SHM, how we can find out the velocity at particular time at particular given position, what is the acceleration. Actually, we discuss about the basic kinematics of the oscillations as well as we already discussed what is the total energy that in SHM. A particle is performing simple harmonic motion. What is the kinetic energy of particle? How kinetic energy vary with position? What is the potential energy? And apart from all these two energy, we also discuss about the total energy. Okay. And we also know how the graph is vary and how the graph is the parabola. So in today class, what is the agenda of the class? Let's take a look. Okay. So firstly, we discuss some numerical problems that is PYQ problems that is based on the energy of particle in SHM. Then next, we just going to cover the and understand the concept of the time period. So there are the different type of systems that involve in the simple harmonic motion, like a spring mass system, like a pulley system. So we just learn the approach how we can find out the time period of any general system, and particularly in today class we take an example how we can find out the time period of spring mass system. Okay, so that is our main focus of the today class, how we can evaluate and what are the basic method that we have to follow, what is the basic steps that involve to finding out the time period or angular frequency of any simple harmonic oscillatory system. The next point that we have to discuss in today class, what is the angular SHM? As we know that we already discussed about the linear SHM, where the net restoring force that is directly proportional to displacement of particle from the mean position, that is x. But what is happening when particle is performing angular SHM? If such same type of formula is going to be used, what is the role of the torque, what is the role of angular acceleration and the angular displacement theta, that we need to understand in the angular SHM. And there are last three points if we see, that is the concept of simple pendulum, physical pendulum and torsional pendulum. These are nothing some different thing. These are the basic application of the angular SHM. Okay, so these are the topics, subtopics that we have to cover in today class. So without wasting the time, let's start the session. Okay, guys. So in last class, we just discussed about what is the total energy of the particle which is performing simple harmonic motion. I hope my audio and video that is clear for all the students. If audio and video is clear, so please give me a message in chat box or comment box so that I will move forward. Come on, guys. Yes. If everything is okay, give me a thumbs up, guys. Come on. Okay. So, guys, what is the total energy of particle? So, sir, total energy is nothing but that is there are two types of energy involved. One is the kinetic, another is the potential. So we just say that this is the sum of kinetic energy plus potential energy. Yes or no, guys? What is the kinetic energy? Anybody? Can you recall me what is the kinetic energy that we evaluated in the last class? You can say that is the sir just similar to half mv square. So just put the value half, that is the mass of particle, and what is the velocity beta? That omega under root a square minus x square. So if we squaring this, we will get half omega square a square minus x square. I hope this is clear. And how we can keep in our mind, that is the simple formula half mv square, just replace the value of v. so that we can remember this formula. What about the potential energy? We also derive an expression for potential energy, and that again very easy, just similar to half kx square. I hope this is clear to everyone. Half kx square. Okay, sir. Okay, sir. Please see here. That is the important term that I want to discuss here. That half m omega square a square minus x square. What about k here, beta? What about k here? What is k here? Sir, k is not a spring constant. Again, I focus at that particular point. K is not a spring constant. In the simple harmonic motion, k is known as the SHM constant. Yes or no, beta? Because it is not always necessary to be always taken spring mass system. There are possibility of n number of system. Those are performing simple harmonic motion. So that's why I am saying that k is depending upon that particular system. So k is SHM constant, and at the starting of this chapter, we already taken one assumption that beta omega is defined that root over k upon m. I hope this point is clear to everyone. Omega is defined root over k by m. Okay, sir, no problem. So can we replace value of k by in terms of omega? Why not, sir? So what we can say here, beta, if we squaring both the side in order to find out the value of k, because we see omega here, so we think how we can convert this k into terms of omega. That's why we using this relation. So this can be written k by m. So what is the value of k, beta? M omega square. This particular formula we have in back of mind, what is omega, beta? If we put the value of k in this equation, what we will get here, beta? Just see here, beta. Half m omega square a square minus x square, and put the value of k, beta. Sir, that is m omega square x square. Oh my God! If we simplify these two terms, they will give us a beautiful result, beta. Please see what is result we are getting here. Sir, the half m omega square x square, that is cancel out to each other. It means whatever total energy we will get here, that is a beautiful expression. Why this is beautiful, beta? What is the reason behind? Because of importance of this formula, that total energy term is independent of time as well as x also. So what is conclusion of this? Sir, we can say that the total energy, all the terms that involve in total energy that defining the system. Mass is the inherent property of system. Yes, sir. Omega, that is related with kinematics. Once a time period is fixed, angular frequency is fixed, it means omega is not going to be changed. Amplitude, this is the distance between mean position to extreme position. If everything is fixed, this is also fixed for a given system. It means total energy of a particle which is performing simple harmonic motion, that is always constant. This is the pickup line of the today class. I hope this is clear to everyone. The total energy that is constant. Sir. What we see here, even kinetic energy is function of x. Yes. Potential energy is also variable, but the sum up of these two energy give a wonderful result that is a constant, and that is very, very important for JEE and NEET also. If you believe me, the JEE main paper is currently going on. In the previous shift of the 10th April, the same type of question is asked. What is the graph of the total energy, including kinetic plus potential energy? So we can say that this is a constant value, and we can also observe where this total energy is half m omega square a square. Okay, sir. Sir, let's feel this total energy in some another aspect. Let's see, beta. Suppose that if a particle is performing a simple harmonic motion, okay, sir, and say this is the mean position. No problem, sir. This is the mean position. Yes. Sir, this is the right stream position. Okay, right stream position. This is the left stream position. वाह sir, क्या बात है? Sir, what is the value of x at this point? This is equal to amplitude. This is equal to minus times of amplitude. I hope this point is also clear. Suppose that if I want to find out what is the total energy at mean position, anybody in this class, what is total energy in mean position? Sir, total energy is the sum of kinetic and potential. And if someone not believing on this formula, then what is the basic approach? You just sum up kinetic plus potential at every point, and believe me, you always will get this same result. So if we want to find out, if we want to cross check this formula at mean position, so sir, mean position, it means at mean position kinetic energy is maximum and potential energy minimum, that is 0. Oh my god, it means total mechanical energy at mean position is nothing but kinetic energy maximum. I hope this is clear, because potential energy is 0. Oh my god, what is the kinetic energy? Half mv square. What is the velocity, beta? Sir, maximum velocity or maximum speed, that is a omega. So that is a square omega square. Check it. Check this formula. This is valid or not? This is valid or not? Okay. So what is the total mechanical energy? One important terms that I want to discuss here. Listen, listen, listen. The total energy is equal to maximum of kinetic energy. This is nothing but beta, that is the maximum of kinetic energy. And at which point maximum kinetic energy is occur? Tell me, come on guys. At which point total mechanical energy is occur? Kinetic energy will be maximum. At which point? Mean position. Very good, beta. Mean position. Yes or no? Because we know that at the mean position, speed is maximum and potential energy is minimum. At the same time, if you want to calculate total energy at extreme position, anybody, what is the total energy? Sir, extreme position means speed equal to 0. It means kinetic energy equal to 0. Okay, this means whatever energy that is because of the potential energy. It means potential energy is maximum at extreme position. I hope is it clear for everyone, beta? Is it clear why I want to say at extreme position kinetic is 0? So all the energy due to potential. Oh my god! And what is the formula of potential energy? Half k x square. Half k x square. Sir, in place of k, can we put this value? Why not, beta? Why not? And what is the x for extreme position? What is the value of x? Sir, a. So this will equal to a square. This will equal to a square. See this is what we will get here. The total energy at mean position equal to maximum kinetic energy. The total energy at extreme position, that is the maximum potential energy. It means energy is always conserved. If kinetic energy is minimum, then potential energy will become maximum. If vice and versa is also true. I hope there is important conclusion, and you have to note down all these important points, beta. What I want to do here, beta, we just club two graphs. One is the kinetic and another is the potential that we already derived, that we already draw in the previous lecture. So, sir, we know that half kx square, this is the graph of the potential energy. Yes, sir. And this is the graph of the parabola downward kinetic energy. Yes, sir. If we sum up these two energy, each and every point, what we will get here, that the sum of these two energies always constant, and this value is equal to half m omega square a square. So that's why I will draw, if we see that this total energy, let us highlight this term. So what we can say, the total energy is constant. That's why we will draw a line parallel to x-axis. Okay, and this value is here, and this value is for minus a2 plus a. I hope this graph is, बेटा ये ग्राफ ना यहाँ जाना चाहिए. Yes या no, बेटा? Yes या no? Inside deep on your bottom of your heart, You just remember this graph, beta, because this is very, very important, and each and every year the question is asked from this graph. Okay. So I hope if you are able to understand this graph very beautifully, then you can give me answer of the next question that I will ask. Tell me correct answer. Firstly, we have to read the question. You have 50 seconds to give the correct answer. Come on. And you can comment in chat box whatever answer you are getting. A simple pendulum, a graph is plotted between the kinetic energy, potential energy against the displacement. Which one of following represent correctly? Tell me correct answer. Anybody, come on. Come on, come on. What is the correct answer? GNV Kolhapur, GNV Rajkot. Can you tell me what is the correct answer, beta? Yes, Yanu. Sir. We know that the potential energy is the parabola upward, kinetic energy is the parabola downward. We know that, sir, at mean position, kinetic energy is maximum. In this graph, maximum. At extreme position, kinetic energy is 0. Yes, sir, 0. So which one is the correct answer? I hope everybody will get option number D. Yes, Yanu, beta. Yes, Yanu. I hope you can understand the nature of the question. On the same concept, the question is asked, that is the JEE Main 2019. And tell me correct answer, beta. You have 1 second to solve this problem. What is given in the problem? A particle undergoing simple harmonic motion. Okay, sir. Has a time-dependent displacement. Okay, sir. And the displacement equation is given in this form, that x as a function of time equal to a sine pi t divided over 90. In this particular problem, we have to find out the ratio of kinetic to potential energy of particle at t equal to 210 seconds. How we can solve? Anybody in this class? Can you tell me? What is the correct answer? What is the correct answer? Come on, guys. Can you tell me what is the correct answer? Come on. What is the approach, beta? What is the approach? Sir, how we can solve this problem? Let's see the solution. I hope you can solve this problem by yourself. Sir, here kinetic to potential energy is asked. First of all, we have to write down the kinetic energy. What is the kinetic energy, beta? Half m omega square a square minus x square. I hope this is clear to everyone. Okay, sir, but we don't know the value of x. The x is given in the general form, but we have to find out at 210 seconds. Firstly, we have to calculate the value of x, that sine pi t upon 90. In which time the value is asked, beta? 210 seconds. To put the value here, that a sine pi, in place of t, put 210 divide over 90. If we cut this value, this will 3, this will 7. And this is nothing but a sine 7 pi upon 3. Are yes, Yano, guys. Sir, what is this value? Sir, this can be also written in the form of 2 pi. How? 2 pi plus pi by 3. Can we write down this? Give me thumbs up if I can write down 7 pi by 3, that using 2 pi plus pi by 3. And sine 2 pi plus theta, beta. So that is the first quadrant angle. That is the sine theta. This will nothing but sine pi by 3. Oh my God. We will get the value of displacement. And what is this value, beta? We know, everybody know, sine pi by 3 is nothing but root 3 by 2. And this value equal to root 3 by 2 into A. Okay. It means we can write down the kinetic energy, beta, half m omega square A square minus. In place of x, we can put this value. So this will become 3a square upon 4. If we solve this value, beta, half m omega square, and if we take LCM, this will become a square upon 4. So this is very easily we can say m square omega square a square divided over 8. This is the value of kinetic energy. If we know the formula, easily we can tell the correct answer, beta. And how we can solve such type of question? There are n number of questions that is asked in the previous JEE Main and the NEET exam. So you can solve each and every problem. And it is my confidence that you can solve each and every problem related to SHM, whatever asked. If you follow that the simple approach. Okay. Sir, what about the potential energy? What is the formula, beta? What is the formula of potential energy? Let us take some another color. That potential energy is, sir, half k x square. But we want to write down k m omega square. And what is the x square, beta? X, in place of x, we can put this value, that half m omega square root 3 square, that is the 3a square divided over 4. And I hope this will equal to m omega square a square divided over 8, and that into 3. What is this? What is this? This is nothing but beta kinetic energy. So we can write down that potential energy is nothing but kinetic energy into 3. What is asked in the problem? Ratio of kinetic to potential. So we can simply say kinetic divide over potential is nothing but 1 by 3. Kinetic divide over potential is nothing but 1 by 3. So option D is the right one. Option D is the right one. That is the simple problem that is asked in the JEE Main 2019. And the similar type of concept that is again asked in the JEE Main. And in this particular question, I expect from you guys to just solve the given problem. Come on, guys. Let's start the solve. Come on, guys. Let's solve the and tell me correct answer. And tell me correct answer. Your time start now. Your time start now. I'm looking at your comment. So please comment the correct answer. Please comment a correct answer. Agra, Bombay, Calcutta, or Delhi. Tell me correct answer. Come on, guys. Nobody is responding. Please solve this problem. Sir, first of all, read the question at least 3 times, beta. Read the questions and taking a pause after reading one paragraph and write down the necessary informative information. Some students again and again, they have always a query, sir, if we have very good in concept, we revise and recall all the formulas, but even we can't solve the numericals. The mind will become totally blank. If we see the very good GNV, KNR, you are doing a great job, beta. Correct answer, beta. Yes, yeah. So what is the logic behind, beta? Ki sometimes if question that come in front of my eye, we unable to think. My mind will become totally blank. Why this is happening? And what is the approach that we should follow to avoid such type of situations? So first of all, whenever you read the problem, make sure at least read the problem 3 times and break the problems in paragraphs. And in all the paragraphs, whatever some informative information that you will attain, write down in systematic manner. And at last, when we read whole scenario, whole problem, try to draw the diagram and try to connect all given data and whatever asked in the problem, and what you see, definitely you will get answer. So suppose this type of question where a particle is, what is given, beta? It is given that a particle is simple harmonic motion. So first of all, we have to write down, okay, SHM is going on here. Amplitude is so here we can write down amplitude on x-axis. About x equal to 0. What is the meaning of x equal to 0, beta? This is the mean position because particle is moving around x equal to 0. Okay, sir. When its potential energy is equal to kinetic energy. So first of all, if you want to draw the diagram, in particular problem, there is no roll-up diagram. But for the better understanding, if we draw the diagram, please see, for only you guys, I will share this information to you. Okay. So please be serious and follow the given concept that I discussed here. X equal to 0 here, sir. That amplitude is A, it means that is the plus A, that is minus A. This is the, on the basis of basic information, we can draw this diagram. And it is asked that the potential energy equal to kinetic energy. That question is over. Potential energy is equal to kinetic energy. And for which x this is happen? Say this is the particular x where the value of potential energy, say this point is P, where value of potential energy is equal to kinetic energy. So how we can write down the potential energy? That half K, again write down m omega square. Say this distance is x. Okay, sir. What about kinetic energy, beta? Half m omega square a square minus x square. Okay, sir. Sir, see half m omega square, half m omega square. Yes, cancel out. So what we will get? X square equal to a square minus x square. If we solve this beta, we can simply say that 2x square equal to a square, and x is nothing but beta plus minus a upon root 2. Here minus a upon root 2 is not available. If this is available, we can also put. But what is the correct answer, beta? A upon root 2. I hope this is useful to you. How we can approach such type of problem. Let's start and learn some new concept. Okay. So before going to start the time period concept, one important thing that already I have discussed with you, but I want some more confidence on particular concept so that you can solve variety of problems. Okay. What is the concept? What is the meaning of equilibrium? Anybody this concept? Equilibrium means net force equal to 0. Okay, sir. And net force equal to is 0 for which particular x, that is known as the mean position. This equilibrium position is also known as the mean position. Okay, sir. Whenever we will get mean position, then what we have to do? For finding out any question that where we have to find out the time period, firstly we have to find out the mean position. Write down this. First of all, we have to find out either we can say equilibrium position, either mean position. So what is the first step, beta, for finding out the time period? Finding out the equilibrium position, and this position is also known as mean position. How we will get, beta? Just whatever force is given equate to 0, and whatever value of x or y, that is depending upon the particle is moving in which direction, that is corresponding to equilibrium position. The second step, beta, what is the second step? Listen carefully. After once you get equilibrium position, just displace your particle from equilibrium position, slightly displacement given to the particle. So we can say a small displacement given to particle from equilibrium position. Okay, sir. Small displacement we have to given. Keep this point, that is very important. What is the next step, sir? Again write down net force equation for a new position. Again write net force equation. What is the net force equation, beta? That F net equal to ma. Again write down this equation and see that fourth step, is this net force that is equal to kx. If their single power is x is involved, so we can sure that sir, that a is nothing but that is the km by x, and this term is equivalent to our omega square. So here our omega square will equal to k by m, omega will equal to under root k by m, and we know that omega is nothing but beta 2 pi upon capital T. So what about the time period? We can directly say that 2 pi root over m upon k. 2 pi root over m upon k. So what is the step, beta? Tell me, come on. Sir, first of all, we have to find mean position, then slightly displace the particle depending upon in which direction particle is moving. Suppose particle is moving in x direction. After getting the mean position, displace the particle either plus x or minus x small displacement so that we can recognize the nature of particle. Is any force that bring the particle its original position? If such type of force is involved, we can say such type of motion is the SHM. But we don't say mathematically. For mathematical proof, we have to prove such type of equation that acceleration is proportional to x. It means if we displace particle in positive x direction, then acceleration is acting in negative x direction. That means negative sign we don't put here because we already see that restoring force is a force that acting opposite to displacement. That's why we can't put negative sign here. In some books, if negative sign is given, that is good. But we already considered that if the net force is restoring in nature, so that is always opposite to your given displacement. Yes, Yanu? And once we will get this equation, we directly write down this time period. We directly write down this time period. So I hope this whole flow chart that you can understand how we can approach and how we can find out the time period. If everything is okay, so please give me a thumbs up in the comment box. Come on, guys, give me a thumbs up if this is clear. And let in next slide we see a question. Sir, how you can prove and find out the time period of SHM? If everything is okay and you can clearly understand the given concept, please give me a thumbs up so that I can move forward. Okay. This is the beautiful question, and the single question that clear a lot of concept to you guys. What is given in the problem, beta? Firstly, we have to understand the problem. A particle of mass 100 gram is released from x equal to 10 meter, and its experience a variable force that is the function of x. Okay. What is asked in the given problem? In first part, it is asked to find out the equilibrium position. In second part, it is finding out the amplitude of the oscillatory motion. Amplitude of the oscillatory motion. Okay. Minimum value of x coordinate. It means at which point particle can move in negative x. D, prove the motion is the SHM. And in the last part, what is the time period of SHM? So what we do here, by using a single problem, we want to clear all important concepts that are related to SHM. So please, let's see how we can approach such type of problem. First of all, we have to listen whatever I discuss here. Listen very carefully, very seriously. Okay. So what is given here? Try to understand some important pickup point that released from x equal to 10. Anybody in this class, can you tell me what is the meaning of released? What is the meaning of released? Released means the particle velocity at that particular point is 0. So whatever, whenever released is given in SHM, we have to understand that is nothing but that is stream position of the particle. That is stream position of particle. So let's draw a simple line where we can show our particle, because particle is moving in x direction. It is clear by seeing this, and it is saying that suppose if this point is x equal to 0, and if particle is releasing from x equal to 10 meter, it means at this point speed of particle is 0. Are you guys agree with me? Are you guys agree with me? Why I am choosing speed equal to 0 at x equal to 10 meter? Because it is saying in the problem it is released, and it is also give an indication if a particle is released at this point and their speed is 0, it is nothing but that is the rightmost point of the particle, that is the amplitude. We can also say this is stream position of particle. This is stream position of particle. How many of you getting my point? What I want to convey with you? If particle is released, it means speed is 0. If speed is 0, so there is only point that is the stream position. So this is the stream position. Okay, sir. Sir, where is the mean position? Is mean position is x equal to 0? No, 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 no. Never tell such type of nonsense thing, beta. Okay, always listen carefully. If somebody asks to me in particular problem, where is the mean position? So what is the funda for mean position? Anybody can tell me what is the funda for mean position? Come on, tell me how we can find out the mean position. Whatever force is 0, just equate to 0. Okay, so we can say कि for mean position, sir, for mean position, and the another name of mean position, that is the equilibrium position. So what we have to do here, beta? We just equate our force equation equal to 0. Once we equate 8 minus 2x equal to 0, that x equal to 4 meter. Oh my God, this is a point where the net force on particle is 0. So we can clearly say that sir, x equal to 0 if we assume here. So I think somewhere here that x equal to 4 meter. And this particular point that we searching, that this is the mean position. Once we will get mean position, extreme position we already find out, then we know that the gap between the mean position and extreme position, and that particular gap is known as the amplitude. Are yes or no, guys? Tell me yes or no. So we can say that this particular gap is known as the amplitude, na sir. So we can clearly say, sir, this is our amplitude. And what is the value of amplitude, beta? What is the value of amplitude? We can say this is 10. From here, this is the 10 meter. From here, this is the 4 meter. So this value is nothing but 6 meter. So I hope this is clear to you. What is the equilibrium position? That x equal to 4 meter. That is the answer of the first part. What is the amplitude? That a equal to 6 meter. Again, tell me one thing, beta. If the particle is moving in rightward direction at x equal to 10 meter, then particle also moving in the backward motion from mean position, and the same amplitude the particle will possess, that 6 meter. So if particle is moving in this direction, then where will be the left extreme position? So we can say that at the left extreme position, we have to minus the given value of amplitude from mean position. So if 4 minus 6, we will get x equal to minus 2. And this value is nothing but left extreme position. Yes or no, guys? Yes or no? Because we can say that this gap is again equal to 6. So in this way, we can also locate what is the minimum value of x coordinate where particle can reach. That is nothing but beta x equal to 2 meter. Yes or no, beta? And the next task, prove that the particle will perform SHM. Then what we have to see? We have to follow the given step in the previous slide. Sir, equilibrium position, we already get. Small displacement we have to given. Okay, this is our next task. So what we have to do? What is our equilibrium position? That x equal to 4 meter. Sir, we get our equilibrium position that x equal to 4 meter. So we have to displace slightly in either direction. Suppose if we given a small displacement in positive x direction, this is the positive x direction, and this is our main position, and say this particular small displacement is the capital X. Okay, sir. Then what we can write down the force here, beta? We can say that in this condition, we can write down our net force. See here, 8 minus 2. From mean position, we have to slightly displace x. So our particle will reach at this point. And always keep in mind this displacement is not too large. That is very, very small. Okay, because we want to check the nature. So we can say, at this particular position, what is the coordinate of particle? This will be equal to x plus 4. Because originally particle will at mean position and be slightly displaced by amount of x, so that the final coordinate of particle will become x plus 4. If we solve this value, this will equal to 8 minus 2x minus 8. And we can say, oh my God, what we'll get? That we will get f net equal to minus 2x. Sir, I will become very happy after seeing this result. Why, beta? Why? Because in such type of result, such type of restoring force is always only happen for the SHM. And our teacher tell to me, whenever net restoring force that is equal to minus times of kx. Why I put minus sign here? Because minus sign tells about the particle will moving in the opposite to displacement. See here, we displace the particle in this direction, but net force is acting in this direction. It means it satisfies the condition of the SHM. Restoring force always acting that opposite to displacement. Okay, sir. And the net force is proportional to single power x. That is again very beautiful thing. Sir, what we can write down the net force? Sir, mass into acceleration. No problem. What is the acceleration? Minus k by m. Okay, sir. So in this manner, we can write down here, beta. So again, we can say what is the value of k here, beta? The value of k here that is given to. So what is omega square? That is k upon m. So if we compare this equation with our standard equation, the value of k equal to 2. 2 upon mass. And in the question, mass is given 100 gram. 100 gram means 0.1 kg. So what we will say here that omega square that will equal to beta 20. So omega will become under root 20. So omega that can be written as beta 2 pi upon capital T. That is under root 20. So what about the time period beta 2 pi root over under root 20 second. I hope this question will help to clear a lot of micro concept regarding to SHM. How we can find out the mean position, how we can approach for amplitude, and we have to know that in particular problem, if we quite obvious that is whole the process, it is not depending upon where it the particle is initial position, that this 8 is not affect our final solution of the problem. Because if this 8 is not given here and only force equation is given that minus 2x side we, then again we will get the same answer. So there is a conclusion that we will run from this problem. That what is the conclusion beta? The important conclusion is that beta, our constant force does not depend the time period of the SHM, because we know that in this particular problem 8 is constant. If we don't consider 8, we directly say that f equal to minus 2x. And if we see this equation, we directly say k equal to 2. And we can write down the answer in one single line. Okay. So what we observe here is, sir, the whenever constant force involved in the particle that is performing simple harmonic motion, it does not affect the angular frequency, it does not affect the time period. Okay, beta. Let's move further. Next, what is the spring mass system? So let's talk about what is the spring mass system. And in the first case, if we consider a horizontal spring mass system, see here, suppose if we consider a spring mass system in a smooth surface and the mass of the block is m, that is attached with a unstretched spring having spring constant k. What is the meaning of unstretched? Sir, meaning of this, as original condition, there is no deformation in the spring. It means block will at natural position. Okay, sir. Sir, what is happening? We just give a external force F to this block. Okay. So if we apply a F that is constant in nature, and what will happening, beta? Anybody in this class, can you tell me what will happening? If we consider the ideal spring, massless spring, and at natural position, if we apply a force, and this surface is smooth, okay, what will happening? As we apply a external force, this force want to pull the block. When block want to pull, then spring will come its elongated position, And once spring will enter its elongated position, the spring force come into picture. And spring force that is acting to opposite direction of external force F. So what we consider here, suppose after time t, what we consider is if this block will reach at this point and say this is the natural position and say the spring will suffer x elongation, x amount of elongation. So can you tell me what is the value of the spring force here? Sir, spring force is k into x. And where x is measured from the natural position. Okay, sir. So this is the kx. This is the kx. Sir, as we increase the elongation, spring force is also increases. So there is a time come when external force will be equal to spring force. And when external force equal to spring force, what about the net force? What about the net force? Sir, at that time, net force on block will become 0. And this particular position, we can say this is the mean position. This is the mean position. Say at this position, this is the natural position. And spring will suffer x naught elongation. So what is the spring force beta? K x naught. What is the external force? Sir, this is the constant. And suppose at this point, if the net total force on the block will 0, so this is nothing but this is our equilibrium position. This is our equilibrium position. We can say that F equal to K x naught. Let's start the SHM. Sir, why we are doing such type of things? Because in order to find out, in order to check whether block will perform SHM or not, firstly we have to find out the mean position. We will find out our mean position. This is the important relationship. This is our mean position or this is our equilibrium position. Our story will start from the mean position. We have to keep in mind. What is the next step, beta? We just displace this particle slightly in either direction. X or Y, C. If we displace this particle in the positive X direction, C beta, C. Please try to understand my feeling because time is always a constraint for us. So let's give the importance to time. If we displace this particular particle from mean position, say this amount is X. Can you tell me what is the total spring force? Because we already know that this deformation is x naught. Again, if we displace particle that small amount of x in order to check the SHM. We already know that external force is constant in nature, that is not going to be changed. Yes or no? Am I correct, GNV Jalgaon? Yes or no? Am I correct? Because we apply the external force or that it is constant in nature. Already we considered. So what is spring force at this moment? Anybody can tell me, GNV Rajkot, what is the spring force at this moment? At this moment, that is the very special moment for me. Sir, something like a birthday for me. Special moment, beta. Sir, K. What is the elongation from natural position? X naught plus X. Beta, X naught plus X. Why we are writing out here X naught plus X? Because in spring force, the elongation or deformation that is always measured from the natural position. Most of the students that they are always confused. Sir, where Kx naught, that always confusion. But we have to clear whenever spring force is involved, always measure the force, always measure the deformation from the natural position. Okay, sir. It means what is the net force? What is the, write down the fourth step that we already written here, CCC, beta. Write down the net force equal to MA at new position. So write down this equation here. F net. Sir, this force and one is the external force. One force is rightward direction, say this is positive. We don't know which one is a positive, which one is negative. So consider any one is positive in rightward direction, then the force that is acting in the minus x direction, that you have to consider negative. So F is acting in rightward direction, say this is the positive force. And what about the K x naught plus x, sir? This is acting in leftward direction. That's why I am taking negative here. No problem. F minus kx naught minus kx. See one thing, beta. See one thing. We already find out that F equal to kx naught at mean position. So put this value. Oh my God, kitni khushi. Sir, this will cancel out. And F net equal to minus kx. F net equal to minus kx. First of all, we have to sort out the matter of minus here. What is the importance or significance of minus sign here? Anybody? Sir, minus sign tells about the restoring force that acting, that want to bring the block its mean position. Are you agree with me? Are you agree with me? Yes or no, guys? Okay, that is the importance of the negative sign, because the net force always bring the block its mean position. Okay, when we see, we can say we m into a equal to minus kx. So acceleration is nothing but minus km upon x, and this term is nothing but beta, that can be written as omega square. Omega we can directly write down the k by m. Once we will get omega, we can comment over the time period. I hope this is understandable for all of you. Okay. And again, I will give a homework problem for you guys. If we suspend the spring in a vertical position, suppose this is our spring, and if we attach a block having mass m, spring having spring constant k, then we have to find out what is the time period if we slightly displace the block, and in order to check the block is performing SHM or not. So this is homework problem. This is homework problem number 1. Again, write down the second problem, beta. What is the second problem? See here. If this spring block system is placed on an inclined plane, in such a manner, and say initially spring is unstretched, that is spring constant k, mass m, angle theta. What is time period if we slightly displace the block from its main position? If we slightly displace the block from its main position. Yes or no, guys? Yes or no? How we can find out? Anybody can tell me what is the approach that we have to follow? Firstly, we have to follow the main position. Then we have to slightly displace the block. Then write down the net force equation and then see is net force is equal to minus kx or not. Okay. And whatever constant that we will get, that is the coefficient of x that decide the value of time period. So in today's class, we learn some importance crunch point of the energy and how we can find out the time period of the given system. In the next class, we will continue with the time period and we will try to understand the concept of the angular SHM also. So I hope you enjoy the session. If you enjoy the session, that is grateful for me. So thank you so much for attending the class, guys. Let's meet in the next class. Okay. Okay, beta. Thank you so much.